what we're going to try to do here is we're going to try to graph a cosecant function. And if we're clever, and maybe in the last couple of videos we kind of started to allude to how we can do this, is maybe a better way is to graph its reciprocal function, and then from that maybe we can graph this particular function. So first of all, cosecant, what was its reciprocal function? It was sine. So let's see if we can graph y equals 2 times the sine of 2x. If we can graph that, then from that we can graph the cosecant function. So we already see what its amplitude is. We see that the highest point that that graph is going to reach is at 2. So let me just gently mark that in there. 2 and negative 2 is its amplitude. Now I don't want those dashed lines to be confused with horizontal asymptotes. They're just there just for little guideline markers. And now we know that we have a period modification here as well. So we had to find its period by taking 2 pi divided by the b. So its period equals pi. So let's go ahead and mark that one out. 0, pi, and we can mark some other part, half a pi. And so there we have some of the key parts to graph the sine function. We know where it crosses the x-axis at, here at 0 and pi. It also crosses at the halfway point. And then we want to figure out what happens at a quarter of the way through and 3/4 of the way through. And since we know it's a sine function, it's going to have a maximum on the first quarter and have a minimum on the second quarter. So the graph then will gently so there's my sine of 2 sine 2x. That's what that graph looks like. And then if we want, we can go ahead and extend it out and look at it on the other side. So let's put negative pi halves. And let's just see. There, so we got that run of the graph. Okay, with that, we have some information now that we can go ahead and graph its reciprocal function. So one of the first things we can look at is find out where its vertical asymptotes are at. So its vertical asymptotes are where our sine graph equals 0 at. So we have a vertical asymptote. It's not defined there, not defined there, not defined at pi halves, not defined at pi, and so forth. All right, then what we can do is we can continue to take the reciprocal of these functions. And so if I see the graph here, I see what's going to happen. It's going to come down right there. Do the same thing right here. Down here. And over here. So by graphing the sine function, I was able to go ahead and take the reciprocal of that, which is its cosecant function, and then go ahead and, well, not really mirror that about the sine graph, but to go ahead and use its reciprocal type of an idea. So we know that we found its vertical asymptotes. We know that all the values are going to be greater than its amplitude and less than a negative value of this amplitude. And then it's hedged in between these vertical asymptotes. So the graph is going to keep exploring both boundaries of those vertical asymptotes all the way to either positive infinity or negative infinity. Now I'm going to do one more example after that, after this one, to kind of get a sense again and get some more practice at this.